In problem 9.5, part A asks you what the dielectric constant of plastic is. From the equation sheet you got capacitance equals K, which is what we're trying to find. You got this constant. You have area, and it's looking at that distance. So they tell you that the capacitance is 0.05 microfarads, so that actually becomes times equals, we're just looking for K. They tell you that the area is 1 square meter, so we're just going to have 1 here. And then the plastic is 10 to the -3 meters thick. So after you multiply, so it becomes, after you change everything over, so you get K equals 5 times 10 to the -8 farads times 10 to the -3 all over 9. You get K equals 5.65. And that's part A. So part B, double I, asks you what the time constant for the circuit is. So for any capacitor, tau equals RC. So R you've got is 2 times 10 to the 6 ohms times the capacitance, which is 5 times 10 to the -8 farads. So your tau, after you work out math, becomes 0.1 seconds, and that's B double I. Okay, so part B, triple I, asks you to find the magnitude and sign of the final charge on the bottom plate of the fully charged capacitor. So we know C equals Q over V from the equation sheet. So if you're trying to find Q, it's going to be Q equals CV. And we know capacitance is 5 times 10 to the -8 farads, and your voltage is 30 volts. So your charge is going to end up being 1.5 times 10 to the -6 coulombs. That's a C. And because the flow is going clockwise, it's going to be negative. And that's B triple I. So part B IV asks how much electrical energy is stored in the fully charged capacitor. So from the equation you have U C equals 1/2 QV or equals 1/2 CV squared. You can use either one of these because you just found the charge in the last problem, and the problem gives you capacitance and voltage, but because if you get this one wrong, then you might not get full points. Might as well just do the ones that they give you. So the energy equals 1/2, and this would be 5 times 10 to the -8 times the voltage squared, which is 30 squared. So it's going to be so your potential energy is going to be 2.25 times 10 to the -8 joules. And that's BIV. Part C asks what is the new voltage across the plates after you charge up the capacitor and take out the plastic sheet. So we've got C equals, oh, this one's better. C equals K A over D. So when you take out the K, you're basically saying you're going to divide the C by a constant. So in V equals Q over C. This C is also going to be divided by K, so it's going to be V equals V over C, which brings you to, so you're going to have your original voltage, which is 30 volts, so it's going to be 30 volts, and your K was, you found earlier, which is 5.65, which will get you 170 volts, which is C. Okay, so part D asks, if there is now more energy stored in the capacitor, where did it come from? If there is now less energy, what happened to it? There is now more energy stored in the capacitor because you took out the dielectric, because there was work done taking out the dielectric. And with that, you are done.